Throughout the course of this tutorial, we will be working towards modeling a facade system that consists of highly detailed elements that all know its place in the system and that ultimately will be turned into documentation in both 2D and 3D format. But the first milestone we have to hit is to create a notion of the facade and where all the panels are and what elements are represented in which location. As you can see here on the screen, this is the goal for our first set of exercises. And what we see here is basically a very simple way of representing a facade system by basically creating single surfaces that represent the location and the type of a facade element. As well as for each panel, we will create some more notional elements such as the glass pane, where the mullions are, where the transoms are, and where the sills are. Also, for each panel, we will create a corner point that is labeled top left, bottom left, top right, bottom right. And all these elements together will allow us to create a more detailed version of this panel down the line. All of these items, at the very least, know which panel they belong to, and they will also get assigned some attributes that we need in order to take these elements to the next level in the next detail. So without further ado, why don't we start at the beginning and create our first elephant definition? So we'll open up Rhino, we start Grasshopper, and our first task is to create a point grid that will identify the panelization of our facade. Now most of the things that I will be doing are actually typical Grasshopper exercises, so I won't go into too much detail as to how to do it, because this tutorial is basically about everything that we do to make an elephant workflow instead of just a traditional Grasshopper script. So I will focus on the areas that deal with elephant, and I will go over the traditional Grasshopper functionality a little bit quicker. In this case, we are going to create a facade panelization on a part of a sphere. So we will start with creating a sphere. Primitive sphere. Then we will give it some properties. So let's say this sphere should have a radius of 50 meters. So I just double click on the canvas, on 50 meters. Now we have our sphere. Get this out of the way. You can actually see the sphere in our viewport. Now, we don't want an entire sphere, we just want a portion of the sphere. So go Utilities, Isotrim, and we have to specify a two-dimensional domain U and V for the subsurface. So we go math, domain, two-dimensional domain, and for this we need 4 sliders, so let's create 4 sliders. 1, 2, 3, 4. Hook it up, so. Now of course the U value, the maximum value should always be larger than the minimum value. So something like this. Something like this. Provide this to the domain of this surface. And now we see that we are getting a nice little subsurface on which we can place our panelization points later on. This will be the basis. Now, typically what you would do in Grasshopper In cases like this, you have defined a piece of geometry. You will go right-click on the canvas and hit Bake. Now that geometry gets translated into Rhino geometry and baked into the document. It is great. Of course, it's how Grasshopper works. But it gets baked on the default layer, or at least it gets baked on the active layer in your document. And the color will be by layer, the line type will be by layer. So there are basically not a whole lot of customization options. Furthermore, now when I decide I want to tweak the parameters of this shape a little bit, when I go hit Bake again, I will just get a new piece of geometry in my Rhino model. The old one is still there. This can of course become very messy very quickly, because now I have two of these surfaces in my model and already I forgot which one is the latest one, is the one that I want to use. And of course, as you go through several iterations, your model rather quickly becomes completely saturated with geometry that you do not know anymore what the function is. So this is where the first elephant component becomes very useful. When we go to elephant, go to bake, we will find the bake objects component. We will hook up the surface to the geometry, which is the first input of this component. And now this is basically just replacing the Grasshopper bake command. Whenever we activate this component, it will just act as if we were to right-click this element and hit bake. I will demonstrate that. Activate geometries here, and everything is set to the default attributes. When I would make some changes to the geometry, like so, I would hit bake again. I'll just add the geometry to the document. So nothing new there. However, there are a few more inputs in this bake component, one of which is called bake name. When I specify a unique name for this component, it means that everything that is baked with this component will always be replaced if I bake new geometry with the same component. So why don't we go ahead and grab a panel and specify a bake name. And let's make it a name that actually means something. So let's say this is our base sub sphere. Assign that to bake. Now when I activate this component, the geometry is created. But when I make changes to the geometry and I hit the bake button again, previous geometry that was baked with this component is automatically deleted and is now replaced by the new geometry. And this is of course very useful because this is a very simple way of keeping your Rhino model clean. You're basically always baking the latest version and all previous versions are no longer there. Of course, if you want to keep any of the previous versions, you always have the possibility of saving that model with a specific name and keep that previous version for later reference. But while this is great, it will still create this object on all of the defaults, the active layer, default color, default line type, etc., etc. And of course, we want to change that too. So one of the other inputs of the bake component is attributes. We want to assign attributes to this object. So we go elephant attributes, define object attributes. And there's a bunch of attributes we can assign here. Down here we have name, layer, color, and material, which are the typical attributes that are native to Rhino. On top of that, we have user keys and user values. I will get into the specifics of those later on. For now, let's say we want to assign a layer name. So we just take a panel and we define a layer name. In this case, I would say base subsphere for layer name. It's pretty good. It's pretty descriptive, so I'm going to stick with that. We might as well, if we assign a layer name, we might as well assign an object name, because it's good practice to name your objects for future identification. So in this case, I'm just going to go with the same name. And we can specify a color. Why not? Go to params, input, color swatch, nice color, bright red, assign it as the object color. Now we can connect these attributes to the bake component attributes input. And now when we hit bake again, we'll get the nice red surface that has a name base subsphere. A new layer was created, base subsphere. This object is assigned to it. Again, if I make any changes to the geometry, bake again, it's all still big. The same attributes, the same layer. It's just replacing the previous geometry. This is the very basis of what Elefront is about, and I'll show you more